So, all in all, what we have done for this chapter, chapter 3, is, here we're dealing with all these different different people, different patients, different tables. And so we went ahead and created this table, and take a look at this table that we've created. There are things that we've created at the column level. There's a primary key. There's a check constraint at the column level. And what is interesting about the check constraint is that you notice that we have a column here, height, and we refer to it here as well, okay? So when you're dealing with things at the column level, when it comes to the check constraint, the column itself is repeated again. And then here we are dealing with the F name. We're coming up with a constraint keyword when you want to go and come up with a name for your constraints. Not null can only happen at the column level. And the default can only happen at the column level. And then you can have the composite key. So here's a unique composite key that we're dealing with, and that can only happen at the table level. And then here's another table level constraint that we're actually giving a name to. And then here's our table disease, and there's a primary key. And so, and then here's patient disease. And so here we're seeing how we're using the references keyword to go ahead and connect. And this is our foreign key. And we're also using this undelete cascade, which means that what? If you go ahead and remove something, so what does the undelete cascade mean? Can somebody help me? Undelete cascade. If you go ahead and remove from where? If you, if you delete from the parent table, right? And then if you remove a record from the parent table for which there's a connection in the child table, well, all the records in the child table that are connected to the record that you want to go in and get rid of in the parent table, they will be removed as well. And I know that this is like a mean, analogy, but once again, we're saying that if you want to go ahead and get rid of the children, okay, but if there are parents around, okay, so that's fine. But if you want to go to get rid of the parents, well, then you just go and sort of cascade on over and get rid of the children as well, okay? Because the children cannot live without the parents. So that's what we're saying. All right. Now, that is happening here at the column level, and we said that you're able to go and create the constraint also at the table level. So here we go. When you're dealing with things at the table level, notice that you're using the foreign key syntax. Why do you need that foreign key syntax? Very quickly. Yes?
It references another column from another table.
Well, so foreign key, that syntax right there, it's referencing a column, but which table is it referencing at this point? The very table that you're in. I'm in this table, right? In this table, it says, why don't you go ahead and consider disease ID as your foreign key? And then here is where you actually go ahead and connect it to another table. You connect it to the table disease, more specifically to the column disease ID. Yes? Okay, so once again, foreign key, that syntax is used to go ahead and identify a column within the table that you're on. And references is identifying the column in the other table that you want to connect to. Okay, and then here's our composite primary key. And then here is where we want to go and insert stuff. Remember to always insert into the parent table first. And then you can go ahead and do an alter table. You can add, you can go ahead and rename a column. You can go ahead and disable a constraint, in this case, constraint primary key. You can drop a column. You can drop a constraint if you know its name. And then if you want to go ahead and get some information about the kinds of constraint that you have on your table, then guess what? You just go ahead and go to the user underscore constraints table, and that will give you the information. Okay. You're able to delete from the patient table. You're able to go ahead and rename the patient table to sick person. You're able to go ahead and find out about the structure of the table, delete from the sick person, truncate. Which one takes less time? Truncate. And then you can go ahead and create an index on the table. You just identify the column and identify the name of the index. Which indexes are created for you automatically? Primary key and unique key. You don't have to do anything. And what is going to be the name of those indexes? The same. the same as whatever the name of the primary key or the unique key is. If you give it a name, that's what it is. If you don't, well then Oracle will give it a name. All right, and then you drop an index like this. The one common mistake that folks make is that when they want to go ahead and drop an index, they use the alter table syntax. Don't. Just go ahead and use the drop index, okay, just like dropping a table. When you drop a table, what happens to the constraints? Do they get dropped as well? Do they get deleted? Yes, okay. The indexes, does it get deleted? Yes, everything gets deleted, okay? And then here is once again going into the user constraints table to go and find out about that. And remember that when you're checking, to go ahead and put the name of the table that you're checking against all in uppercase. And so there is that, and there is the man. He's the king. Look at that. Doesn't he just, he's just sitting there like a king. And of course he was good friends with Steve Jobs. Yeah. He was the photographer. Yes. All right. For like his wedding and stuff. So let's go ahead and just, I should now bring up and let me go ahead and do a freeze here. Okay, and I'd like to go ahead and bring somebody's homework so we can see it. Who feels good about what they have done? So, yes. We can take yours, okay. And I know who you are, Yulia, right?
Yes.
But then your last name is,
P-E-R-E-D.
what is it, E? P. I have two problems. The first problem is that I can't see quite as well. Oh, there it is, okay. All right, so let's go ahead and just take a look at this first item. So this is the group create that we're going to be looking at first. And then what we'll do is after the group create, we'll go ahead and take a look at the group constraints. And then after the group constraints, we'll go ahead and okay. So let's go ahead and unfreeze this. Okay, and so let's go ahead and find out what is going on with homework create. All right, so here we're going to go and create a table of students, and so the requirements are as we see. There is the primary key, there's all of that, there's the age, number, okay, and then there's the date of birth. We say that that's a number as well, so there's that. Okay, so far so good? Any complaints? Okay. I guess I shouldn't say complaints. Any suggestions? Okay. All right. So then we come here. And then here, we're going to go ahead and take that table. And then we're going to go ahead and just add this unique constraint. There it is. And that's a composite. And then over here, we're going to go ahead and check the age. Okay, so there it is. Age is between 10 and 15. It's a check constraint. And notice that we have the constraint keyword. And there's the name of the constraint. Okay, so there we have it. And then we want to go ahead and add a column. There it is, add the name of the column, and then the type associated with it. And then we want to go ahead and add a date of birth. Or actually, we want to modify. So date of birth was numeric, but now we want to go ahead and modify it. And we want to say, you know what, it is of type date. And also there is the constraint, it's not null. Okay? And then we want to go and create a composite index. So there it is, create index. We come up with some kind of a name. on, you identify the name of the table, and then there is the composite index right there on SSN and data code. And then we want to go ahead and create a column. There it is, transferable. We identify its type. It's a not null, and we're adding it. And then this one right here, okay, we once again go ahead and add a constraint, give it some name. It's a check constraint. And then there is the name of the column. And then these are all the different conditions that we can have, all in single quotes. If you want to go ahead and drop the H column, there it is, drop the H. And then we're going to go ahead and describe the table. So that's what that is, okay? And then we are going to the user constraints. Notice this is all in uppercase, okay? And then that's all the stuff that we are looking at, okay? Now we're ready for the second table. Here is the second table. It is unique and not null, okay? So we need to make sure it's kind of like a primary key at this point. Because a primary key, you can't just leave it empty. You have to put something. And of course, it cannot be a duplicate, which is what we are acquiring from that combination right there. So then we want to go ahead and create a primary key. So there it is, add constraint, the name of it, and then a primary key. And then you identify what that is. And then we want to go ahead and create an index. There it is, we want to go ahead and create an index. So create index, the name of the index on the specific column. But then it's going to go ahead and give us an error message. Is that so good? Why are we getting an error?
It's already the index is already created by unique.
That's right. Okay, so class description is already unique, right? And if it's unique, it means an index has been created for you automatically. And so you cannot go ahead and create an index on the very column that already has an index. Okay, so there is that. And here we go. Select. So once again, we want to go and find out what is happening with all that. And yep, okay, so then here we have the third one. There's that table. And then after the table has been created, let's go ahead and add a primary key, add the constraint name, there's the primary key. It is composite, the foreign key, okay? So we're doing add, and whenever we use the add, okay, notice we are identifying the foreign key, and this identifies the column in that table that is going to go ahead and connect to another table, and there's the column in that other table. And once again, we're wanting to go and find out what these constraints are, and we're getting just a listing of their names, and there's all that. Yeah, what do you think? Happening. Okay, so that was easy. And so we're thinking, well, can we look at one more? How about the constraints? Okay, so there it is. It looks like you went ahead and switched over from SQL Plus to SQL Developer.
Yes.
SQL Plus sucks?
For me, yes, because I'm using the virtual machine and.
Yes. Okay. All right. Because you're using a Mac. Yeah. Okay. So in this case, we have a check constraint, salary, and then salary again. Now notice salary is actually being dealt with 2 times. So look at that. Salary is there, and salary is there as well. Do you see how my cursor is showing up? I just learned that. I didn't know how I could do that. Okay. So yeah. And then here, not null constraints. So there it is on the party description. And then you're going to go ahead and disable. So there it is, disable constraints. And then there's all that. And then here we are adding an additional column. Okay, so there it is. And I guess we're adding a whole bunch of things here. Adding primary key, adding that, okay. All right, and you're disabling some foreign key right there. And then you're dropping the constraints. So there we have it. Okay, so we're good on that. Let's go ahead and just go to this last one here. In this case, we are creating this table that's been created right there. And we create another table. and then we're gonna go ahead and drop a column. There it is. And then she checks it right here, scrub. And then we're gonna go ahead and add a column, and then we check it again. Notice it's actually added to the end. And then we're gonna go ahead and add that one. It's a not null, okay. And let's see here, what is happening here? So add, okay, fine. And then here we are adding unique. There's that. And then here we have a primary key that is being created at the column level. And then she's going against the user constraints table to go ahead and just see if everything is actually correct. All right, good. What questions do you have for me on this? No questions? Yes?
When I go constraints, I get message table editor. Then I see constraints square. I see no group.
Okay, so you dropped a constraint,
Yes.
but then when you go to the user constraints table, it's not dropped?
No. Marker, no show.
I see. So, you know, if you could just show me that syntax so I could look at it, and we can just do it right after class to go and we'll take a look at your code and find out what's going on. Okay, anyone else? Anyone else? Anything, yes?
Can you explain the index a little bit more, because I still kind of confused with this.
As to what an index is?
Yeah, so what kind of, how it's useful, something like that. It's like,
Well, you know, think about this. When you're actually looking up information, okay? So like right now, we have a whole bunch of people, okay? We're sitting in this class. And people are sitting a certain way, right? And I go ahead and do a lookup based on, let's say, the first name. I could go and say, hey, what is your first name? What is your first name? What is your first name? And I may find, you know, the individual like here, they could be here, they could be there. So this could take a long time, right? Now, what if we do this? What if we actually go and organize it based on, let's say, the first name, such that we have all the A's here, all the B's there, all the D's there, all the whatever, okay? So then this way, now when you're searching, you can actually go ahead and jump to the place where you need to go, because you know exactly where the A's are, you know where the C's are, you know where the D's are. Things are just not scattered randomly, right? So if I'm looking for the Z, you know, then I can just go and go to the very, very end and look for that individual. It's kind of like a telephone book, you know, when you're looking for information, if things are organized according to the first name and you know the first name, then you just go ahead and alphabetically look for the person and you just find it.
okay, so
Okay.
like you just create an index for that, I think that variable, and then just like when you try to look something in that variable, you just go to the variable and look for it.
Well, you shouldn't say variable, but column.
Column,
Okay,
yeah,
all right.
column.
So yeah, so basically you just make searches a lot faster. You just quickly go to the place where you need to because of the way that you've arranged the data. Because once again, we can arrange, let's say, everybody based on first name. But then we can also arrange everybody based on last name. We can also arrange everybody based on their address. And then depending on the kind of search that we want to do, we can go ahead and go to the kind of arrangement that we've come up with.
Okay.
Yeah? Yes?
And we have to check constraint if we have any option.
Check constraint and,
And we have yes or no.
Ah. right.
So I use for I use it multiple times till I find it. But I see her it's different from me.
Oh, okay.
Her work is different.
Okay. Well, we'll have to go and take a look and see what you've come up with. Yeah, and then we can see, but using that check constraint is certainly one way. Anything else? Anyone else? No one. Okay. All right, so with that in mind, let's go ahead and continue on. Once again, if you're actually emailing me, you know, telling me that there's a problem with some part of your code, give me that snippet of code so I can see exactly what you've typed in and what message you're getting, okay? So both the Oracle error message and also your syntax. So we need both of those. Okay, good. Let's go ahead and go over here. You know, and by the way, this is it. This is the guy, you know, you're thinking is the impossible. Look at that. at 9 months, okay, so he had pneumonia. His unmarried 19-year-old mother gave him to her aunt and uncle to raise in Chicago. And so this guy, his adoptive father, lost his real estate business. And so he just ran off. He was very rebellious. So this was quite the individual, okay? They should probably make a movie about this man as well, okay? It would be kind of interesting. All right, so now let's go ahead and find out how it is that you insert. Now, we've already seen how you're able to insert, okay, a bit, but let's just get into it a bit more. So let's go ahead and deal with textual information first. So here we have all these things, varchar, char, char2. Now, varchar, we know it's flexible, which means that if you have 3 characters, okay, you can go ahead and fill in all 3. You can go ahead and fill in 2, you can go ahead and fill in 1. And it just sort of expands or shrinks, okay, within that bound. It doesn't fill it up with any spaces, it just takes the information that you give to it, okay? So if you put in A, that's what you have, just A. If you put in AB, that's what you give it. ABC, that's what you give it. But if you make it ABCD, then that would be an error message because you've gone outside the bounds. Now with char itself, that really is equivalent to char 1. So it's the same thing. And in this case, we have char 2. So it means you have 2 spaces. Now, of course, with the 2 spaces, if you go ahead and put in, let's say, A, it's going to go ahead and make it A along with a space. If you go ahead and make it AB, of course, you're fine. But the thing that makes this different is that in all scenarios, you're going to go ahead and have 2 characters. And it will pad it with spaces to go ahead and make sure that you get the 2 spaces. Yeah? Okay. And here I go ahead and show you some examples. So this is the varchar, this is the char, there's that, so everything is being filled up. This one right here. Now, you know, when you're actually providing values, notice you just say values, and then this corresponds to column A, this corresponds to column B, this corresponds to column C. Those are, now you can't see anything because I've marked everything, okay? But anyway, they correspond in the sequence in which they appear. Column A, column B, column C, column A, column B, column C. Now, maybe you do not want to go ahead and follow that order. And so you could change it. So you could actually go ahead and say, you know what, I want to go ahead and insert into this table. And then you go ahead and identify the order that you're interested in. And when you insert the data, it's going to go according to the order that you've identified here. So column A, column B, column C, that's for column A, column B, column C. But if you wanted column B, column C, column A, well, that's the order that you can go ahead and follow. Or maybe you don't want to go ahead and provide a value for everything. You just have column B, column C, column B, column C. Now, what happens to column A? Because, you know, we're putting in all this rows of information. And in this case, we're putting in information for column B and column C. What's going to be sitting in column A? What do you think? Because we did not provide a value for it, right?
No.
No. And null means what?
Nothing.
And so blank space, you know, so let's go ahead and just use that proper terminology that will appear on the test. No, null, so null means void of data. That just sounds very technical, doesn't it? Okay, it's void of data. Okay, so it's not blank spaces, because spaces is, you know, spaces is data. I guess you could say blank spaces. Yeah, you could do that. I like it. Okay, but void of data is the more technical term. Okay, all right. So and then this is all the stuff that we just went ahead and put in. And notice we didn't provide anything for column A, and it's got nothing in it. Now, what happens if you go outside the bounds? Well, this is an error message. This one right here, column A, and you go ahead and put in only 2 when you actually can allow for 3, that's okay. It'll just go ahead and take 2. And you can actually go ahead and just confirm the actual length here. There's a function that Oracle makes available to you, and you can go ahead and find out the length of what you just put in. And so here I go ahead and display the data and the actual length. So let's go ahead and just go down here and look at it. So take a look at this. This is the actual information, and this is the length of the column. 3 characters, 3 characters, 3 characters. That's null. So look at that, the length doesn't give me anything. 2 characters, and so that's what I have. All right, and so there is this. And then here we're putting in something in column C, which can go ahead and take, so look at that. That's char 2, which means it actually gets blank patterns. And so if I was to go ahead and do this, column C with length, even though I just put in one character, it's going to go ahead and tell me 2, because it's going to go ahead and pad it with spaces. And so you're saying, I don't believe you? Okay, fine. And, I did not paste that in here. So you have a right to not believe me. But believe me, that's truly the case, all right? All right. Now take a look at this. Here we are inserting into column A all of that, so that's no good because it goes beyond column A. We're just putting in 2 things. We go ahead and check the actual length. Oh, this is what we just did. Okay, okay, so we're done with that, okay. Oh, here we go. Okay, so take a look at this. This is for column C, which is a chart 2. Okay, so that's what column C is. Now, so if I just go ahead and put in just a C by itself, even though that's one character, so this is column C, okay? Even though that's one character, it tells me that the length is 2. And so that's just emphasizing that same point. Now, what about inserting numbers? Now, if you remember with numbers, well, there's something kind of interesting. Here you can go ahead and just say number by itself. And here you can go ahead and put in any kind of number. It can be a real number, it can be a whole number, it can be a really big number. There could be many, many significant digits. It doesn't care. It'll store everything, okay? But then if you actually just go ahead and use this syntax right here, which is just this stuff with the parentheses, it's going to go ahead and just allow you to store whole numbers. That's it. Whole numbers is what you actually get. And then right over here, you have the 5 and then you have the 3. And so then it's going to go ahead and control as to the kind of number that you can put in there. And so let's go ahead and find out what is going on. So let me just go ahead and go down here and see what is happening. So remember, column 0 is any kind of number. This one is a whole number, and this one you can go ahead and put in a real number, okay, which means there's a decimal point, but it actually has to have a particular flavor, okay? You can't just put in whatever you want. So let's find out what is going on. So this one, I am putting in any kind of number that I want. This goes into column 0. This one, of course, is a whole number, and this one is 23253. Now, how does that correspond to the 5 and the 3? So what this is saying is that ultimately what is happening is I'm going to go ahead and deal with 5 digits. Out of the 5 digits, 3 of them are going to go ahead and belong to the right of the decimal point. Whatever is left over is going to be for the left. So in essence, really, you get 2 digits here and you get 3 digits here. Yes? And that gives you a total of 5. And this 3 right here is actually telling you how the 5 will be allocated on the left-hand side and on the right-hand side of the decimal point. Yes? Does that make sense? No, it doesn't make any sense. Okay, so I guess to make, well, so, so basically what we're saying is that if you're dealing with a number, 5, 3, 6, 7.2, is that 5 numbers? It is 5, okay? How many numbers do we have on the right-hand side? 1. And how many numbers do we have on the left-hand side? 4, okay? What does this tell us? This says you can have a total of 5 numbers, okay? And it says when you go ahead and take the 5 and you subtract 3 from it, you come back with a 2. This 2 that we're looking at, that's going to go ahead and tell us how many digits we can have on the left-hand side. Do we have more than 2 digits?
Yeah.
Yes, so that's no good. Okay, so this thing right here is telling us about the allocation of what can be on the left-hand side, what can be on the right-hand side. Let me go ahead and give you some more examples here. It'll make more sense.
Before you go further, can I ask some question?
Yes, by all means.
In the column 4, that you see the number 5, so you can put any number to represent the whole number, right?
I'm sorry, and which one?
Column 4.
This one?
Uh-huh. The number after the number 5. I mean, you can put any other number to represent this become the whole number, or it just had to be 5.
Well, so what you're inserting does not have to be a whole number, okay? But keep in mind that what you will actually end up storing will be a whole number, and the number of digits cannot be more than 5.
Oh, okay.
Okay, so if you try to store 1,000,000 in there, that's more than 5 digits.
Okay,
correct?
okay.
And so guess what? Oracle is going to go ahead and complain.
Okay.
All right.
Cool.
But let's go ahead and just go through these examples, and then let's see if after these examples it's still not making any sense. Now, what happens is, let's just say that you want to go ahead and insert a record into column 0, column 1, and column 2. And you want to go ahead and just put nothing in there. So you can go ahead and use the keyword null. You can also go ahead and put in single quotes, just with no spaces in between. So that just means that you've just entered a row and they're all void of data. There's nothing in there. You could do that. Okay, or whatever. All right. Now let's go ahead and just come over here. In this case, we have 1, 2, 3, 2, 3, and 2. Remember that this one was the 5, 3. This one was the 5, and this was just the number. Now, you can go and store any kind of a number for that. Yes? That's all good. This one, do we have less than 5 digits or just 5 digits? Yes, so that's all fine. And then right over here, do you think that that could actually fall in that category? And the answer is yes, because once again, the syntax that we're looking at is something like this. So this is a total of 5, 3 of which are on the right-hand side, 2 of which is on the left-hand side. Okay. Now, so the question that actually may come up is, what happens if you have a number that is larger? Will there be any rounding that will be done? I mean, what happens with the rounding, with the truncating? What is all that going to do with all these numbers that we have here? And so let's go ahead and find out. In this case, this is column 0, which is of course just plain number, and you have a big, big number. That accepts it. It's okay. Any kind of number would be valid. Then you come over here, you go ahead and put in that number. Any kind of number would be valid, and it will store it as it sees it. Okay. And so there's all that information. So notice there's the null record that we just inserted. And of course, in this case, we're just putting in column 0. We didn't provide a value for any of these other ones, which means that those are null as well. Now let's go ahead and deal with column 1. In column 1, if you remember, it was number 5. Yes? So number 5, this means, well, look at that. We have way too many digits. So that's not going to work. Okay? It goes beyond the 5 digits. Now, what about this one right here? This certainly is not a whole number. Well, that's okay. It certainly looks like it's more than 5 digits. That's okay as well. What we are interested in is at the end of the day, when this does become a whole number, is it going to be 5 or less? So we know that because we're going to be storing a whole number, we're not going to be storing any of this stuff right here. So what are we going to do? We're going to go ahead and see if we can round it up or down. So at this point, what do we get?
12.
Just the 12. That's all. That's all that we store. And so take a look at that. There's the 12. Now, what happens if you actually go ahead and do a 12.5? Once again, that's a number 5. So that part of it is certainly going to be less than 5 or equal. And this one right here is going to go and round it up. So this means we get a 13. Look at that. There is a 13 that we get. Now this one right here, we get a 12.45. Once again, that is going to go and round down, which is the reason why we just get a plain 12. All right, and so we have this one right here. Now, in this case, we have 12.245. Now, once again, remember that for column 2, what we had was a number, and then we had 5, 3, which means that we have 1, 2, then dot, 1, 2, 3. At this point, you notice that we have more than 3. Is that a problem? Is that a problem? Yes? Well, this says one row created. Are you not seeing this? So apparently it's not a problem, is it? Okay? Because what is it able to do? You know, at the end of the day, you know, if you have, let's say, 12 points to, you know, for 9, if you want to go ahead and just make it up to 2 digits after the decimal point, it can be 12.25, right? You can round it. Or if you want to just see only 1 digit, it would be 12.2. Or if you just want to see none of that, it can just be plain 12, right? So you could actually go ahead and do something with the significant digits by rounding them up or down as needed. So if you actually have more digits, it's not a problem. You just go ahead and take a look at that. Can you round that? Yes. So then what do you see? 12.255. So it'll just round it. And so we are still within the bounds of the 5-3. There is the 3, there is the 2, that gives us the 5. Let's go ahead and come over here. In this case though, 1, 2, 3, 4, 2. Once again, we have a 5, 3, 1, 2, dot, 1, 2, 3. Notice that there's absolutely no way that we can go ahead and make that fit into that space. 1, 2, 3, 4, we can't truncate it, we can't round it down, so that would be an error. What about this one? Once again, it's 5. There is no way to go ahead and round this down to go ahead and fit it within those 2. That cannot happen. What about this one? Well, we can go ahead and round this, right? So this is 23.235. And so that's what you have. Now, what about this one right here? So, do you think we can do this? Well, so we can go ahead and just put it in a space that looks like that. That 9 is going to go and round that up. Round this up. Round this up. Round this up. Round this up. And at the end, what number are you going to get? 100. And can we fit 100 here? No, so you can't do that. Okay, yes. So you guys are thinking this is all very easy, isn't it? Yeah, not a big deal, all right? Now, what about inserting dates? You know, when you go to Europe, you know, when they write the dates, let's say you want to go into today's what, the 8th. How do they write their dates? What is that format?
Day, month, year.
So they go ahead and do like 8, 10, and then 18, right? That's how they do it. But in America, we go ahead and do things the right way, don't we? Okay? We go ahead and do it this way. And this should become the global standard. Always.
Always.
And that's the way it is, right? Well, what is going on is, apparently, I guess, depending on where you are, depending on the kind of data that you're actually getting, things could be formatted in a different way, couldn't it? Now, we know that beneath the scenes, okay, inside of Oracle, things are only stored in a certain way. So, for example, for us, okay, regardless of what is sitting inside of our head, what kind of data you have, at the end of the day, it's just nothing but a bunch of chemicals. That's all it is. That's the common denominator. That's how things are actually being stored inside of us, right? Now, there could be a lot of variation in terms of the actual data itself, but it's all in the form of chemicals. So for Oracle, there is a particular way in which information is going to be stored. There could be all these different formats, but inside of it, things are going to be stored a particular way. What is that particular way? I think we've talked about this before. There is a particular format that Oracle recognizes, understands, and it doesn't need to go and translate it into any special way. And that route is what? What is that format? Did we talk about it?
Day
Okay, so
dash 3-letter abbreviation for the month dash and then the year, and I think it can be 2 or 4.
right, so we could go with that. Okay, so if you go ahead and provide Oracle this information, it says, oh, you know, this actually just matches my DNA. I don't need to go ahead and do any conversion. It's all just going to go inside. Okay, but if you decide to go ahead and give the information in this way, somehow Oracle needs to go ahead and translate this into this. Now, there's an issue that actually comes up. How do we know, given this information, what part of it is the month, what part of it is the day, what part of it is the year? because once again, we've just arrived at the conclusion that depending on where you come from, this could be the date, or maybe this could be the date. So how do you do it? Well, you need to go ahead and give Oracle then some information so that it knows how to go and convert from here to there. And so that formatting information is a must for Oracle to be able to store the date. Why? Because you see, with dates, we need to know what part of it is the month, because we need to go and do some calculations. Let's say we have a date of birth, and I want to go and find out how old someone is. I need to go and take a look at what? Today's date, and subtract it from the date of birth, and that tells me how old the individual is. That's math that I need to go and do. And to be able to go and do that math, I need to know exactly where the month is, where the day is, where the year is. Well, so what occurs, all right. So what occurs here is we're going to go ahead and say that, you know what, depending on, let's say, the way that you want to go ahead and see the information, there are all these different formatting commands that are available to you in Oracle. And these are the formatting commands that we're going to go ahead and just provide. So if you want the full 4-letter month, or 5-letter month, or whatever month, you just go ahead and put in month. If you want the 3-character, if you want the digits, if you want the Roman numeral, and the same thing is true with days. If you want to go and see the number associated with the day of the week, if you want to go and see the actual day itself, if you want to go and see the numeric value of where it's in the year, and if you want to see Wednesday, let's just say abbreviated, the 2-digit, the 4-digit, and BC AD, so you can go ahead and deal with all of that to format things exactly how you want. Now, this is true not only for inserting a date, but also when you want to go ahead and display the date, because you may want to go ahead and see the information being displayed in this way. And of course, as we've indicated, you're able to go and store both the date and the time. And so maybe you want to go ahead and format the time in all these different ways. So let's go ahead and find out how this works. So look at that. There is the date, data time. If I want to go ahead and insert into dates, there it is. This is what Oracle understands. We don't have to do anything. It's all good. Now, the question that actually comes up is when I'm storing this, is this 11? Is this 2011? Is this 1911? What the hell is it? How do we know? So, because we don't know, okay, well, at this point, it's going to go ahead and just say, you know what, nobody's probably talking about 1911, because all those people are dead now. Is there anybody from 1911 who's still alive? Do we have anyone? I don't think we have anyone. Well, anyway, so since everybody's dead, from that era, we must be talking about this, and Oracle recognizes that. But there has to be like a point at which Oracle decides to go back or forward. Being that is a little difficult for us to remember. So at this point, the question is it 1945 or is it 2045? So what do you think people are dealing with now? Is it 2045 or 1945? 1945? No, I think, I'm surprised. You guys are the newer generation. You need to be forward-looking. So 2045 is what we want to be looking at. So, by the way, did you see this on the news, that the world is going to end in about 12 years? Did you, I mean, this is not like some, some proclamation, from some prophet, but, they're talking about global warming and all this, and so all the calculations that they have done, based on that math, we have another 12 years, and that's it.
Stop studying.
So listen, I think we've been here for too long. We need to go on, and it's amazing, how much the news actually affects you. When we sit down with the family, we were with my brother-in-law, and there was all the soda, there was all this really yummy cake, and usually we stay away from that. And so I saw him eating all this. I said, "Hey, Lord, what the hell are you doing? We can't be eating this crap. This is gonna kill you. We haven't drank soda in such a long time. What about all this cake? It's too sweet. You can't be doing stuff like this." You know what he says? He says, "Iraj, I don't give a shit anymore." I said, "What the hell's your problem? Why would you say that?" He says, "The world is going to end in 12 years. and I'm going to go ahead and eat whatever I want. And it's just amazing how much this information actually affects you. So I held myself back. I did not eat anything. But this morning, I was eating a lot of good things. All right, so anyway. So for this reason, because these things are ambiguous, when we are actually wanting to go ahead and insert, we probably do want to go ahead and put in the 4-digit year and not go with the assumptions that are made behind the scenes. Now, let's just say that you want to go ahead and insert what is happening with the current date. You want to go ahead and put in the current date and time. Well, sysdate is a special word that Oracle uses, and that'll just go ahead and register the current date and time. And so select date test, okay, and so there we go. And so you put in all this, you put in all that, and so there is that, there's that. Now, let's say that you want to go ahead and display the information. When you're displaying the information, what are you doing? You're displaying just a bunch of characters on the screen, aren't you? So what occurs is you're going to go ahead and display a bunch of characters on the screen. Now, you can display this stuff in just this normal format. You could just say select, for example, column from the name of the table, and Oracle will go ahead and display to you in the normal default format, okay? Which is the 2-digit day, the 3-character month, and then of course you have like 95. It'll do that. But if you want to go ahead and see it in some other format, well then this is what you do. You want to go ahead and see a bunch of characters. You go ahead and identify the column that you're interested in, and then in here, the formatting commands that I indicated. So here you're seeing the 4-digit year, the 2-digit month, and the 2-digit day. If you don't like that format, there is this 2-digit year, 2-digit month, and then this is actually displaying the day itself. And here's another one where you're seeing all of that along with the time as well. This is the 24-hour military time, and this is the minutes, and here's the seconds. Okay? And so let's go ahead and find out how this works. So when you're displaying the information in this format, look at this. It is no longer the default date format that is being displayed. It is the format that you've indicated right there. Or this one right here. Look at that. Monday, Tuesday, Wednesday. That's what we have. Or in this case, you're seeing the date as well, and the time. And so there it is. There is the time. Yes? Okay. Now, what happens when you're actually inserting? Okay? We know that when you're displaying a bunch of characters. And so you go ahead and use the toChar function. It takes 2 arguments, and at least in one way of using it. And here you put in the column, and then here's where you go ahead and put in the formatting information. But what if you want to insert? So when you want to go and insert, what are you inserting? You're inserting a date, aren't you? You see, when you're displaying a bunch of characters on the screen. But when you're inserting, Oracle says you're inserting a date into my date column. So then what you need to do is you need to go ahead, and if you're putting in something that is different from the default date format, then you need to go ahead and say, you know what, I got this date, and I'm going to go ahead and tell you exactly how I've constructed this. 4-digit year, 2-digit month, 2-digit day. So now you've told Oracle exactly how to go ahead and decipher this information. And because it is a date, and you're putting it inside of a date column, you're going to go ahead and use the toDate function. There it is. Here's another one. You're putting in a date, so you need to convert it to date. There is the actual date, and then once again, that's the first part is the year, the day, and the month. And here's another one, and you notice that I have time information as well. And so I go ahead and tell it, you know what, the first part of the time is a 24-hour. Then this is the minutes, that's the seconds. And so we have that. So toChar, when you want to go ahead and display, and when you want to go ahead and insert, you're going to go ahead and use a toDate. And they both apparently take 2 arguments. So let me pause here. What questions do you have for me? Does that make sense? So all that we have done at this point for today is we have examined how to go ahead and insert something into a char, into a varchar, into a number, okay? And we've said that, you know what, we have that format, we have just that format itself, or we can have nothing in there. But the varchar, you can put that. With char, you could actually go ahead and put something there, or you could put nothing in there, okay? And of course, with the date, you have all those formatting commands. You could use the to date, and you could use the to char. It takes two arguments. And so this is for inserting, and this is for display. Yes?
For the hours, how you did HH24, what happens if you want to do it from AM and PM, so 12?
Oh, so you want to go ahead, well, so if you go back up here, look at that. You can actually go ahead and put in the AM or the PM, okay? And then you can actually go ahead and say, you know what, if you don't put in the HH24, if you just say HH, it is by default the normal time. If you wanted military, you go ahead and put the 25 in there. So notice if you just put in HH by itself, it'll give you the normal time, 11, 12, and then it just turns around to 1, 2, 3. And then you can go ahead and, but you probably do want to go ahead and put in the AM or the PM in there as well. Yeah? Okay, anyone else? No one else. Okay, all right, so we are done with that, done with that. Good, 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 good. And now, let's go ahead and do this. Now, some of you are thinking, you know what? I don't like the default date format. I'm gonna go ahead and just pretend as if I'm living in Europe. Okay, so I wanna go and just have a different date format. Okay, you wanna go and just see things in a different way. So what you could do is you could actually change the default date format. You know, it's no longer 2-digit day, 3-character month, and then 2-digit year. Maybe you want to go ahead and change it to this. It would be the 3-character month, the 2-digit year, and the 2-digit year. Maybe you want it to be like that. And so take a look at this. You could actually go ahead and use the alter session syntax, NLS date format, and you can change the format so that it's like this. So this means that when you're inserting or when you're displaying, if you go ahead and want that format, you don't have to do anything extra. But if you want some other format, guess what? You go ahead and use the formatting commands that we talked about. So this means that now, if you were to go ahead and use the old format, which worked before, now it's going to go and complain. It's going to say, no, this is not going to work. So now you need to go ahead and use the new format. There is that. And so take a look at this. This is the old format. It's not going to go and work. Now, let's go ahead and take a look at this. You do dy, mm, yy. Okay? And I'll go ahead and talk about this in just a few moments, but let's not worry about it. Okay? So here we're changing the format. So dy is like Wednesday. Month is like month of 3. And year is like, I don't know, 85. So when you go ahead and change the default date format to look like this, and when you're going to go ahead and do an insert, and you insert into some column, some date which has that format, why would that be wrong? Why would it be wrong to go ahead and change the default date format to something like this?
So 3 simple months. Alter session only 2 simple months.
Okay, so I'm sorry, so what was that again?
Wednesday, 3 simple.
Oh, there are 3 different Wednesdays in the month.
Yes.
Okay, so do you know what he's saying? He's saying that when you're actually inserting a date, it has to go ahead and land on some specific day, right? Within the year. It can be ambiguous. When you say the 3rd month, Wednesday, okay, well, the 3rd month has many Wednesdays, right? Which Wednesday are you referring to? And so for this reason, Oracle is going to go and tell you, I have no idea how to go and insert that. So when you go ahead and come up with stuff like this, you better know what you're doing. All right. Anyone else? So no questions. Okay, so let me go ahead and just take a bit of time and talk about the dual table. Okay. Now, imagine as if I have this table. It's got this one column. Let's go ahead and call it column 1. And it's got some data in there. Let's just say I put in a 5, I put in a 6, I put in 8. Yes? So then I say, select column 1 from the name of the table is called T1. There it is. Yes? Okay? And so it's going to go ahead and display what? 5, 6, 8. Yeah? Now, what happens if I do this? Select column 1. And then I'm going to go ahead and do something else. I'm going to go ahead and say, why don't you go ahead and add 2 numbers? Just say 5, or like 15 plus 20 from T1. I can go ahead and do math. Okay, so it's going to go ahead and display what? 5, 6, 8. And then it's 15 plus 20 is what? 35, right? So 35, 35, 35. Yes, does that make sense? Okay, so this is going to go ahead and repeat for every row that we're dealing with. So if I have in this table T1 10 million records, I'm going to go ahead and see this 35 10 million times. Yes? Okay? Now let's go ahead and just do something else. If I do a select column 1 sysdate from T1, it's going to go ahead and show me the 5, 6, and 8, but then it's going to go ahead and show me the date, which is, let's say, I don't know, 10, 8, 18, 10, 8, 18, 10, 8, 18. Yes? It's going to go and show me today's date 3 times.
No. Increase every row, increase this date change.
No, because sysdate is always, well, it's going to go ahead and change in terms of the seconds maybe, but you know, it all depends on how you're displaying it, but the actual date itself, if you're just looking at the default, the way it's being displayed, it's going to be happening on that same date.
The same date.
Yeah.
I
You were thinking about the micro nanoseconds.
If I do select the last second day,
Right. Yeah, so I mean, we can be very precise and talk about, you know, the nanoseconds, okay? But if we're just looking at even the seconds, all of this is going to go and probably happen within the same second. Okay, so now this is very odd. Okay, so let's just go ahead and now do something. Now we know that when we have a select statement, we don't have to go ahead and display everything that we want. Instead of doing a select column 1 sysdate, how about if I just go ahead and do a select sysdate from T1? What do I see in that scenario? What do you think? So we know what happens when you go ahead and do a select column 1 from T1. It's going to go ahead and display these 3. If I do column 1 15 plus 20, it's going to go ahead and show me these 3. If I do a column 1 sysdate, it's going to go ahead and show me these 3. What happens if I do a column sysdate from T1? What do I see here? I get what?
Every instance where sysdate is in one of the columns.
So if this is the data that I'm looking at, and this is column 1, this is sysdate, okay? Now I've decided to go ahead and show what? Only the sysdate, yes?
Only the dates?
Which means that I only go ahead and see this piece right here. And I see it how many times?
3 times?
1 for every row. Because what you go ahead and put between the select and the from, it actually decides what to go ahead and which columns to go ahead and display. The number of rows are still going to be the same. Are you with me on that? Who doesn't get what I just talked about? Yeah? Are you good? Okay, so think about this once again. if you do a select column 1, column 2, column 3 from some table, and here's column 1, column 2, column 3, and you have all this data. Okay, so this one is going to go ahead and show us everything. Yes? If I go ahead and cross this out, what does that mean? Now I go ahead and see this piece. If I cross this out, what do I see? Now I see this piece. Now, if I go ahead and cross all these out and just put in like 20 plus 10, then guess what? I see 35, 35, 35, 35. If I go ahead, or 30, okay. If I go ahead and get rid of this and I go ahead and put in Cis8, then this means that I no longer see this. Either I just see the Cis8, which is 10, 8, whatever. You know, I see that 4 times. Are you with me on that? But the point that I want to go ahead and get through here is that it's going to be as many iterations as the number of records that you have. Now, who cares? Well, the reason why we care is because nobody wants to go ahead and see the date 4 times, right? I mean, when you're looking at today's date, you want to go ahead and just see that, you know what, it's 10, 8, 18, 1 time. When you want to go ahead and do some math, what is 20 plus 10, you want to go ahead and see 35 only 1 time. So, for this reason, Oracle has a table. It's called dual. Inside of this dual table, it's got a column called dummy, right? And then inside of this table, for that column, it's got a simple 1 row of information. That's it. Just 1 row. You cannot go ahead and insert more. What that means is that when you go ahead and do a select dummy from dual, you'll get an X. What happens if you say dummy and then you put a 10 plus 20? Well, it's going to go ahead and show you X and 30, but you'll see this thing only 1 time. What happens if you go ahead and put a Cis8 here? Well, then you'll go ahead and see 10, 8, 18, but you only see it 1 time. Why? Because there's only 1 record in there. And then, once again, if you want, you can go and say, you know what, I don't want to see the dummy stuff. Well, then you won't see that. I don't want to see the 10 plus 20. Well, you won't see that. The Cis8, you'll see that. So if you want to go ahead and do any calculations, if you want to go and try out any of the Oracle functions, the dual table becomes extremely useful. Yeah? All right, well, looks like you guys are not excited. That's okay. So let's just make sure that, so as far as our assignments are concerned, do we know what's due and what's not due?
Homework 1 is due today, homework 2 is due on the 10th.
On the 10th. Okay, so that's great. And so let's just go ahead and bring this up here.
Insert this Wednesday as well.
Good.
Okay, so that's great. Wednesday, oh yeah. So this is Wednesday, 11:59 p.m. There we have it. So you have all the information that you need to go ahead and do all this stuff. Well, ladies and gentlemen, the best of luck to you.